Alright, so if you have a look at this one, we're given cos 3x and we're asked to prove cos 6x equals something. So we really want to express cos 6x in terms of cos 3x, so a double angle in terms of a single angle. We know that cos of a double angle is the same as 2 cos squared of a single angle minus 1, so we'll use that. So if we have a look at cos 6x, we know that's the same as 2 cos squared 3x minus 1. So we can use that. Because we're given cos 3x, so cos 3x, now we can use the given part is equal to that, and except we've got squared, so we've got cos squared of 3x. If we expand that, we've got 8 cos, oops, wrong expansion, be careful, not looking. So let's square first. So square the first term, double the product, so minus 12 is minus 24, cos to the power of 4x, square the last term, and we've still got minus 1 there. Alright, now 32 cos to the power of 6x, alright, looks like I'm good there, minus 48 cos to the power of 4x, alright, all good there, plus 18 cos squared x, I didn't close my bracket, but all good there, and then minus 1. So we're getting cos 6x equals that, that's all fine. Now if you look at the hence, it's got the 32, the minus 48, but it doesn't have the 18, it's got a 17, and it has a sine squared, and it does not have that 1. So how do we get that? Well, don't forget that that 1, if I just change, 1 is the same as sine squared x plus cos squared x. Alright, so don't forget that. We've also got that we can use. So if I look at it that way, I've got 32 cos to the power of 6x minus 48 cos to the power of 4x. Now I've got 17 cos squareds take away a cos squared. Sorry, 18 cos squareds take away cos squared, which is 17. Cos squared x, brain ahead of mouth, mouth ahead of brain. Alright, so and then I've got a minus sine squared x, which is what I wanted here. So we know that that's also the same as cos 6x. So if I were to solve all of this equals 0, that's the same as solving all of cos 6x equals 0, which is much simpler. Alright, now what is our domain? So first when I had a quick look, I was like, oh, I can't see the domain, but you can see here it says find the acute angles. Alright, so really the domain for x we're looking in is the acute angles, which is 0 to, should we do it in pies? That doesn't really say, we'll do it radians. So just in the first quadrant, but here my angle is 6x. So if I change the domain I'm looking in, I've got to times by 6, 6 on 2 is 3. So I'm going to go to 3 pi here. So if I have a look, I've got 1 pi, 2 pi, 3 pi. Alright, but we're only looking for where cos is positive, so positive here, and then positive here again. So I should be getting 3 answers. Now, you know from our cos curve, like that, so that is our 2 pi, that is our pi. So where are we getting 0? Pi on 2, 3 pi on 2, and there's another one here at 5 pi on 2. So that would be my 3 answers for 6x. And then of course we need to divide by 6. So pi on 12, 3 on 6 is a half, so that's pi on 4. And then this is also just on a 12. So we should get those 3 answers.